Hey guys, welcome to The Kitchen Think, a channel where we talk about interesting scientific discoveries in the field of medicine, health, and fitness. And today we're continuing to talk about COVID-19, specifically focusing on the Johnson & Johnson vaccine that is about to come out. Now, there have been a lot of questions about the science behind it, how efficient it is at fighting COVID-19. So we want to address this and other topics in this video. So let's get started. The Johnson & Johnson vaccine is built on a technology called Adenovirus. Now, Adenovirus is a regular virus, a rather simple virus that kind of gives us the common cold, for example. And what they do is they take the Adenovirus as a vehicle to deliver genetic material into your cells. So what does that mean? Well, they take the shell of the Adenovirus and they put a genetic code there that encodes for a protein that is a part of the SARS-CoV-2 virus. So the SARS-CoV-2 virus being the virus that gives us COVID-19. And that protein that is encoded within the adenovirus kind of vehicle, if you will, is a spike protein of the SARS-CoV-2. So this is the kind of protein that binds to your cells. So what happens is when this adenovirus gets into your cells, it starts producing this, takes the genetic code that's within it and starts producing proteins that are the SARS-CoV-2 specific proteins. And these proteins now act as antigens to stimulate your immune response. So let's talk a little bit more about this in detail. So number one, the adenovirus that they use is an adenovirus that cannot replicate within your cells. So what does that mean? It means that it can deliver material to your cells, but it cannot replicate, make your cells sick, cause more viruses of itself, and infect the rest of your body. So it's not going to make you sick with the common cold. But what it will do is it will deliver that genetic material that the scientists want you to receive. And the genetic material is, again, a small piece of DNA that is specific to the SARS-CoV-2 spike protein. So when this genetic material enters your cell, it starts using your own cellular machinery. It gets transcribed and translated into proteins. And these proteins now get expressed on top of your cells, and your body sees them as foreign bodies, and they call them antigens. And these foreign bodies stimulate your immune system, causing an immune response. And the immune response creates antibodies, but it also creates memory cells, T cells, and all this we discussed in other videos. Now, what happens then is that once these antibodies are produced, and once your immune response is now active, if you were to encounter the real SARS-CoV-2 virus in the future, those antibodies will bind to the same spike proteins on top of this real SARS-CoV-2, making it inactive, unable to bind and infect your cells, thus protecting you against COVID-19. So that's the idea behind this adenovirus. Now, what's interesting is, just so you understand, the technology of adenovirus has been used in science for a long time. I remember myself, Veronica, we've been using this in laboratories. And one example is, let's say you have an experiment to do and you want to study the function of a specific protein. So you grow some cells in an incubator, in a dish, and then you put a virus into these cells that encodes for this the DNA encodes for the protein that you want to study. And once this virus infects the cells, you remove the protein from these cells. Now you can study it. So this technology has been around forever. So it's not a new technology. It's just been now kind of redesigned for kind of a more of a vaccine type of use. So a very interesting kind of a cool concept. Now, let's talk a little bit about it. What is the advantage versus disadvantage between kind of the adenovirus technology versus the mRNA technologies that you see with Pfizer and Moderna vaccines? The first thing I should mention is, because the adenovirus is still a virus versus mRNA technology just takes a piece of mRNA, there's absolutely no virus involved at all. Because adenovirus is still a virus, it takes a little bit of time to produce and purify. And this time means longer time to make the vaccine, and thus you see the Johnson & Johnson vaccine only coming out now, while the Pfizer and Moderna vaccines have been already around for some time because they're faster to produce. So the first disadvantage of the adenovirus technology over the mRNA is that it's a bit slower. The advantage, however, is that it's cheaper. Now, why is it cheaper? Well, if you guys remember, the mRNA vaccines that Pfizer and Moderna uses require really strong refrigeration, actually freezer, like really cold temperatures, minus 20 Celsius, minus 80 Celsius. So when you have to transport and store these vaccines, it takes very special equipment that's very expensive. On the other hand, adenoviruses, because it's a whole virus, it's very stable. It can be stored probably even at room temperature, but I'm sure they probably store it in the fridge, and that's available everywhere. So the advantage of the adenovirus is ease of transport, ease of handling, storage, and so on. So each one has its benefits, each one has its negatives. It's just a different technology that works quite well. And actually, what we want to do today with you guys is we want to first look at a paper that just came out from Johnson & Johnson, where they looked at a study, phase 1 and phase 2 study, kind of where they administered this new vaccine into individuals and saw what kind of efficacy it had.
The article was actually published around January 13th of 2021, so a few weeks ago. And the goal of the trial is twofold. One of the goals is to look at the safety of the vaccine. Now, we're not going to discuss that in this video. The second goal of the trial is to look at the efficacy of the vaccine. And those are the results that we want to share with you today. Before I share with you the results, let's talk a little bit about how the study was done. So they gave the vaccine to people that were 18 years of age or older. They divided the groups, the people that received the vaccine, into two groups based on age. One group was 18 years old up to 55 years old. And the second group was all the individuals that were 65 years or older. Both groups, so all individuals, received either a low dose of the vaccine or a high dose of the vaccine. In addition, in the group of individuals that are 18 to 55 years old, those individuals actually also received either a single dose of the vaccine or 2 doses of the vaccine that was separated by 56 days. Once the trial or the individuals received the vaccine and the trial continued, they analyzed the ability of these individuals at building an immune response against SARS-CoV-2, or the virus that causes COVID-19. The way they analyzed or looked at how effective the vaccine was to take blood samples from all of these individuals, and the blood samples would contain antibodies being one of the main components, one of the components of the immune response that they're measuring, and looking at those antibodies from those individuals that received the vaccine and seeing if those antibodies can block or have any effect on the virus. So let me just go into the data and then you'll understand a little bit. When they took the blood samples and measured the antibodies or looked for antibodies in the blood of patients that received the vaccine, they saw that they could find antibodies that bound to the spike protein of SARS-CoV-2, which is how the vaccine was designed. So the vaccine was working. All of the individuals produced antibodies that recognized the spike protein on SARS-CoV-2. The next experiment that they did was to see if those antibodies were able to protect the individual. And the way they did this is they did an experiment in a laboratory setting where they took the blood samples of individuals that received the vaccine and compared that to blood samples from individuals that did not receive the vaccine or they received a placebo or control. And they incubated those blood samples that have the antibodies with the virus, with SARS-CoV-2 or pseudovirus, and cells. And they looked to see if the antibodies in the blood were able to block the ability of the virus to infect the cells in this experiment. And all of the individuals had antibodies that were able to block the ability of the virus to infect the cells. So they all had built an immune response, at least the antibody production of the immune response. There's obviously other components of the immune response. In addition to that, what I want to note is the fact that when you look at the 2 doses that the individuals were given, when an individual was giving the higher dose, there was always a slight increase in the amount of antibody that the individual produced, and therefore neutralization activity, ability to block the infectivity by the virus. Now, how significant that difference is, we still don't know. We might in the future, but right now we don't know. In addition, when you actually looked at the patients that received either one single dose of the vaccine or 56 days later, a second dose of the vaccine, what the investigators noticed is that with 2 doses of the vaccine, there was again a slight increase in antibody production and therefore a slight increase in inhibition or neutralization by those antibodies against SARS-CoV-2. Again, how significant that difference is, we don't know, but there was a difference. So that's in general what they found in the studies, or that they describe in this paper, and that we wanted to share with you. Now, what do these studies or these observations mean for Johnson & Johnson and for us when it comes to the development of the vaccine and how they're going to be administered in the future? One of the claims that Johnson & Johnson is making is that the administration of their vaccine will be given as a single dose. And why are they making this claim? Well, it's based on some of the observations that we shared with you that are among part of the observations in this paper. What they observed is when they compared the level of antibody response in patients that received the vaccine, a single dose of the vaccine, and compared that antibody response to individuals that had been infected by the virus and successfully fought it off, the antibody response was very similar. So from that, they're concluding that one dose may be sufficient for the vaccination protocol. Now, will that be will a single dose be sufficient or not? We don't really know yet, but that's what they're claiming right now.
On the other hand, they also did a study. If you guys remember from the paper, Veronica was talking about this. They had an age group that was 65 and older. And in that age group, they only administered one dose. And what they saw is that the amount of antibody production in the vaccine in those patients, in those people, was below the level that you would see if those people got the real virus in them, meaning if they were infected with the real virus and then naturally produced the antibodies. So it seems like when you have vaccine administered to the older population, specifically the Johnson & Johnson vaccine, the amount of antibodies they produce is a little bit below the level you would expect, which would be a counter argument for the need of having two doses. So it's actually an interesting question, because you think about Moderna, Pfizer, AstraZeneca, they all have two doses. Mm-hmm. Johnson & Johnson's arguing one, but there is some data to show that maybe two is needed. And this is something they'll have to evaluate based on cost, because cost is also a big factor, but also based on science. Interestingly, guys, while we are recording this video, a new study just came out from Johnson & Johnson. This is their phase 3 study. So what is phase 3 study? Well, similar to the paper that we just talked about, it's a larger study. This is phase 3, so there's about 40-something thousand participants. So there's more diversity, bigger numbers, more variation, so bigger kind of bigger data set, if you will. And they did two different trials here, believe it or not. One trial was done with a single-dose vaccine, and another trial was done with two-dose vaccines. Now, we only have right now data from a single dose. We don't have data from two doses. And what they've shown is that their vaccine has a 66% efficacy against the COVID-19. Now, what does that mean? Well, it means that basically the way I understand it is that people that got the vaccine, 66% of them never got the actual virus. So, they were healthy. But the 34% developed some kind of symptoms and got sick with the virus. Now, a good thing about this is that out of those people that did get sick, none of them developed very severe illness, and they actually didn't need to be hospitalized, I believe.
That's right.
So the idea here is that definitely this single dose vaccine works. But it only works at 66% efficacy. Now, if you compare this to, for example, Moderna, Pfizer, AstraZeneca, that are all double dose vaccines, their efficacy is 90 percentile. So definitely a huge difference. So this again asks the question of Johnson & Johnson: should they pursue the single dose model, or should they consider the two dose model?
Yeah, those are really good points. In addition, we have to consider the new strains. So recently we put together a video talking about the new SARS-CoV-2 viral strains. And these strains are characterized by being more aggressive, more transmissible. And one of the characteristics about some of these strains is that they can, not always, they can have a little bit of resistance against the vaccines. So the vaccines, the Pfizer and Moderna vaccines, are still very efficacious when it comes down to protecting from the effectivity of infection by these new strains of virus. But there's a little bit of a decrease in the efficacy. Now, when you're talking about vaccines like Pfizer and Moderna that have 90% efficacy, decreasing your efficacy by 10 or 20%, that's only down to 70% efficacy. So maybe that is sufficient. And obviously they're starting to show that it is. The question now will be, like in the case of the Johnson & Johnson, if you're starting at 66% efficacy, but now when you're trying to combat a variant, the efficacy is now decreased by 10 or 20%. Now you're talking about 46% efficacy. So this might suggest, is it better to have a 2-dose schedule of the Johnson & Johnson vaccine to be able to drive the immunity up and have more closer to a 90% efficacy? So we don't know what they're going to do. And actually, hopefully soon, well, as soon as they finish, they will have the results from the other phase 3 trial that Yuri was talking about, where they actually did 2 doses of the vaccine. So as soon as we have the data, we'll quickly analyze it and we'll discuss it, and we'll obviously share with you some of that information.
Hopefully you learned something interesting about this Johnson & Johnson adenovirus-based vaccines, guys. Hopefully you learned a little bit about the science behind it, the efficacy. Yeah, there's still discussion as to whether they should go with 1 dose or 2 doses. This is something we still don't know. So we're waiting their results of their trial. And once we know this, we'll pass it on to you guys.
Yeah, for sure. So if you like the video, give us a thumbs up. Also, if you know anybody who might be interested in the topic, feel free to share the video with others. And we encourage you, as well as your friends and family who might be interested in the general topics that we cover in these videos, to subscribe to our channel. So make sure you go and subscribe. That's it for this video. So hopefully we'll see you in the next video. See you later.
Bye.
Bye.